Hello friends, welcome to WebTechSchool. In today's video, we are going to talk about the vertical order traversal of a binary tree. So what is a vertical order traversal? So given the example tree, so the vertical order traversal of this tree would be, let's say in a binary tree, if we draw vertical lines, that will actually give us the vertical order traversal. Let's understand. So let's say in this binary tree, I'm going to draw some vertical lines. Okay, so this is our first line. Okay, now this is our second line. Okay, now this is our third line. Okay, now this is going to be our fourth line, and this is our fifth line, and this is our sixth line. Let's mark these lines as numbers. So if I'll mark this line as 0, and on the left hand side I'm doing, let's say, -1 and -2, and on the right hand side I'm doing 1, 2 and 3. So now we have 6 vertical points. Now what would be the vertical order traversal of this tree now? So we have 6 points. So for -2 we have data like 4, and for -1 vertical point we have 2. For 0 vertical point, you can see we have 1, 5 and 6. So we have 1, 5 and 6. For 1, it's 3 and 8. For 2, it's 7. And for 3, it's 9. So this will be our vertical order traversal of the given binary tree. So this will be our vertical order traversal answer. Okay, so now how we can do this programmatically? So let's clean this a bit. So I'll just remove these vertical lines. What is our objective? Our objective is to print the nodes of this binary tree in this order, right? So how we can achieve this? So for achieving this, so if you look carefully, so the representation of the data how we have displayed, so that can be easily aligned along with a hash table. So let's say we'll take a hash table. Okay, so in the hash table, we need a key by which we can store the data, and in the value we have list of nodes. Okay, so the hash table value will have basically list of tree nodes, because we want against each key there will be multiple nodes. Okay, now the question is how we can get these key numbers aligned. Okay, so what we'll do is, let's say for the root node, we will assign the root node as the key value of 0. Now, every time we are going to the left, we will decrement the value to -1, and every time we are going to the right, we will increment it to +1. Okay, and every time we are incrementing a value, we will add an entry in our hash table. So what we did, first we created a, what we did, we added 0 to the root node. So in the hash table, we will add, let's say key is our 0, and we have an entry called 1. Now we move to the left and we decrement the value to -1. So now we have another key. The key is -1, and for -1, which node is aligned? So we have aligned the node 2. Now similarly, now when we are going to right, we have key 1. For 1, we have node 3. Now let's go again to the left. So from node 2, if I'm going to the left, so I'll do -1. Now for node 2, if I'm going to right, -1 plus 1, so this will become 0. Now for node 1, if I'm going to right, I'll make this as +1, 2. Going left, I'll do 1 -1, so this will become 0. Now for node 6, I'm going to the right, so I'll do again a +1, so this will become +1. For node 7, I'm going right, so this will become +1, 3. So these values are nothing but our keys. Now let's add our entries. For 0, we have 1, and we have 5, and we have 6. Now for -1, we have only 2. For 1, we have 3 and 8. For 2, we have only 7. So we'll print 7. For 3, we have only 9. For -1, we have 2. For -2, we have 4. Okay, so this is our hash map. So now if we'll compare this with the result, only difference between the result and the hash map what we have is we got all the values in a vertical order fashion, but they are jumbled up. So we want 4 to be as our first element, then we want 2, then we want 156. If we'll be able to sort these keys, so then our key will stand -2, -1, 0, 1, 2, and 3. For -2, we can print 4. For -1, it's 2. For 0, it's 156. For 1, it's 38. For 2, it's 7. And 3, it is 9. Okay, so if you can sort the keys, that will be our answer, vertical order traversal. Now let's go to the Visual Studio and let's print the vertical order traversal of the given tree. Right now I'm in Visual Studio. We are working on tree traversal class. So this time we want the vertical order traversal. So let's create the method. So this will basically public static void. So vertical order traversal, and we are gonna receive node root. Okay, so in case the tree is empty, that means the root will be null. Root is equal to null. We will simply return, will not display anything. In other case, what we want a hash map where key is of type integer, which can store integer type keys, and the value would be a list of nodes. Let's create it. So I'll create the hash map, a dictionary object. So in the dictionary, the key would be int and the value would be list of node. Okay, so let's call this as map. I'll say new dictionary. So this is our map. Now we have to do the node increment and decrement operation. How we can do that? For doing that, let's create a queue. So let's say this is my queue. So in this queue, let's clean this. Okay, so in this queue, we'll first push the root node. Along with the root node, we also want to keep track of the vertical points. So this is our vertical points. So let's say these are the entries inside the queue. We'll first push the root node 1 and the vertical point value is 0. Okay, let's take 1 out and for the left node we will decrement by -1, and for the right node will increment by +1 depending on the this value. Okay, so what is it then we are pushing? We are pushing the node as well as we are also pushing the vertical points or the integer point. Okay, now let's take out this. So we are taking out the object which has value 1 and 0. Okay, so whenever we are taking out this value, we will make an entry in the hash table. We will check against the vertical point or the key value. Do we have any key present? No key present. So we'll add key as 0 and value as 1. Okay, now we will take it out. Once we are taking out, then we will push this node's left child and right child. When we are pushing the left child, we will decrement the value by -1. So -1 from 0 would be -1. Okay, and then it will be 3 from 0. We will increment to +1 as it is the right child. So we'll add it 1. Okay, now we'll take out 2 node 2. So now we are taking out 2 -1. In the hash table, we'll check with this key, do we have any entry? We don't have any entry. So we'll simply add a key -1 in the hash table, and against -1 we'll add 2. We have taken out this element. Now let's push its left child and right child. So left child of 2 is 4. So as it is the left child, we'll decrement this by -1. So existing value was -1. So -1 -1. This will become -2. Let's push node 2's right child as well. So right child is 5, and we will increment the value by +1. So that value will be 0. Okay. Now let's take out node 3. We will check with this key if there is any entry in the hash table. So with 1 there is no entry. So we'll add a key and we'll add the value as 3. Okay. So now we will push its left child and right child. Left child of node 3 is 6. So we'll push 6 and we will decrement the key value by -1. So existing value was 1, 1 -1 0. Then we'll push its right child. Right child is 7, and we'll increment the value by +1. So it will become 2. Now let's take out 4. With 2 there is no key present in the hash table. So we'll make an entry in the hash table. Now we will push its left child and right child into the queue. So for 4, the left child is null and the right child is also null. So there is nothing to push. Now we'll take out node 5. So for node 5, the key is 0. 0 is already present in the hash table. So to the value we will add one more entry, 5. Now for node 5, we'll push its left child and right child. For node 5, the left child is null and the right child is also null. So there is nothing to push. Now we'll take out node 6. Node 6, the key is 0. with this key in the hash table already a key present. So we'll add one more entry in the hash table. Now we'll push its left child and right child. For node 6, the left child is null, the right child is node 8. So we will push node 8. As this is the right child, we will increment its key value to +1. So this will be 1. Now we will take out node 7. So we are taking out. So we are taking out node 7. Do we have a key 2 in the hash table? Okay, we do have 2. Okay, that is a mistake. So this needs to be this key, which is -2. Okay, so for 2, we don't have any key present. So I'll just add an entry, and against 2, we'll have 7. Now we'll push node 7's left child and right child. So node 7's left child is null, so there is nothing to push. Node 7's right child is 9. So let's push that. Let's extend our queue. So we are pushing 9, and we will increment it by +1 as it is the right child. So this value will be 3. Now let's take out node 8. So for 1, we already have a key present in the hash table. So we'll just add it to that list, and we will push its left child and right child of node 8. So both are null, so there is nothing to push. This we have taken out. Now we will take out node 9. So we are taking out 9. Okay, so for 3, we don't have any entry in the hash table, so we will add a entry 3, and against the 3 we'll add 9. Now let's push its left child and right child. Left child is null, right child is also null, so there is nothing to push. Now the queue has become empty. So the result what we got is our vertical order traversal, but we also need to do another step, which we need to sort the keys of the hash table. We need to sort. We already have created our map. The next thing what we want is our queue. For queue, I'll take a list. So in the list, we need, so in the list, what we were pushing, the node value as well as its index. Let's create this object. So I'll create, let's say, a public. So let's say I'll create a public class. Let's call this as node object. Okay, so in the node object, it's gonna have a property called public node, which can hold the tree node itself. Okay, and it's also going to have a integer value of index. What will be the index of that node? So now the queue will hold a node object. Let's call this as queue, and this will be basically new list node object. Okay, now inside the queue, we are gonna add our root element. So the root element, the index will be 0. So I'll simply say new node object will add, let's say node will be, what will be the node value? Node value would be root, and index would be 0. Okay, so as long as what we are doing, as long as the queue is not empty or queue dot count is greater than 0, we are gonna pop, we are gonna dequeue our queue. So let's grab the element queue dot element at 0. So this is our element to be dequeued. Let's do the dequeue operation. So queue dot remove at, let's say 0. Now we dequeued this. Now we have to insert its left child and right child. So what we'll do, if element dot node dot right child. So let's insert first left child. So dot left child is not equal to null. Then let's add to our queue dot add. So we'll add new object. Okay, and node will be element dot node dot right child, sorry, left child, and index is equal to element dot whatever was its existing index minus 1 because it's the left child. Now we'll do the same thing for its right child. Okay, so if it's the right child, if it is not null, so we are gonna push its right child and index would be whatever its existing index and we'll do +1. Till now, what we we did the Q, NQ and DQ operation. Along with that, we have to maintain the hash table as well, right? So let's do that as well. Whatever element we are dequeuing, so we'll check if in the hash table, so map dot contains key element dot index. If the key is already present, we are gonna add to that key. So it will be map of key dot add. Let's add the node. So the key value is basically element dot index and add the node element dot node. In case if it does not present, so we'll create an entry. So map dot add. So key would be element dot index and the value will be list of nodes. So we'll say new list. So list of node, we'll just pass in our node value. So this is basically element dot node. That's all the implementation what we need. And the next thing what we need is next operation what we have to do is to our hash map, all the keys needs to be sorted in nature. Okay, for doing that, we can use instead of a dictionary, so I can use a built-in type which is sorted dictionary. So in which the keys will be automatically sorted in nature. Okay, so all the keys are already sorted inside this map. So now we just have to print our elements. So let's print. So for each variable keys in, I'll do map dot keys. Okay, so for each key we have list of nodes. Let's grab the nodes variable nodes equal to, so I'll say map of, let's say keys. Okay, now let's display for each variable node in nodes. What we're gonna do, let's say we'll simply display console.write, let's say node dot data. We'll add, let's say, separator after displaying each node. Okay, then after displaying the node data for a particular keys, then let's add a new line. We'll simply add a console dot write line. Okay, so that's all we need. Let's verify this implementation. Let's verify its implementation. So we have created this method vertical order traversal. Let's go back to its driver code or the main method. So I'll go to program.cs. So in program.cs, I have already created the tree or the binary tree on which we have been discussing our example. So this is the tree 1, 2, 3, 4, 5, 6, 7, 8. This tree I have already constructed in over here. Okay, now let's call our method. So it's basically present in tree traversal dot vertical order traversal. So to this method, we will pass the root of the tree. Okay, now let's run it and see if we are getting the expected output or not. All right, let's open the console window. So this is the output what we have got. Let's verify if this is the correct output or not. So we were expecting, okay, so we were expecting 4, 2, 1, 5, 6, 3, 8, 7, and 9. And this is the exact output what we have got. That's it for binary tree vertical order traversal. If you have learned something today, then please give your thumbs up and don't forget to subscribe. And thanks for watching.